6.3.2 Other Identities. So for these notes, you're going to want to make sure you memorize the identities that we're going to talk about below. So I'm actually going to show you guys how to derive them, and so that way you can always figure out what these identities are. So let's start off with our double angle identities. So if we have the sine of 2x, because that would be double the angle, we can actually use our sign addition identities to help us with this because we know 2x is actually equal to x plus x. So that would be the sign of x plus x. And then we can use our addition identities that we just learned. So that would be the sine of x, cosine x, plus the cosine of x times the sine of x. And so since they're the same, if we just order these with cosine or sine first, notice then that means we would have two of them. So this would be equal to 2 cosine x times the sine of x. So that's my first double angle identity. So the sine of 2x is equal to 2 cosine x times sine x. And of course we have our cosine double angle identities, which we can do the same thing. So the cosine of 2x is equal to cosine x plus x, which is cosine x minus sine x times sine x by the cosine addition identity. So then we have cosine times cosine, which is cosine squared x, minus sine times sine, which is sine squared x. And so that's our cosine double angle identity. And of course, we can do the same thing for tangents. So we had the tangent of the double angle would be equal to tangent x plus x, which is equal to the tangent of x plus the tangent of x over 1 minus tangent x times tangent x, which of course would be equal to 2 tangent x over 1 minus tangent squared x. So we can add that over here. So recall that sine squared x plus cosine squared x is equal to 1 by our Pythagorean identity. And so we can actually take our cosine double angle identity and add some other forms of it. So these are other forms. For cosine of our double angle. So if we take cosine squared x minus sine squared x, and let's say we were to substitute into that for cosine squared, we know cosine squared is equal to 1 minus sine squared. So 1 minus sine squared x minus sine squared x. Notice that you have two of them, so it would be 1 minus 2 sine squared x. So another form would be cosine 2x is equal to 1 minus sine squared, 2 sine squared x. And then we could also do this and replace sine squared x with 1 minus cosine squared x. So we get cosine squared x minus 1 minus cosine squared x by the Pythagorean identities. Distribute that negative there and you get cosine squared x minus 1 plus cosine squared x. So now you have 2 cosine squared x minus 1. And so these other forms for cosine are also used quite often, so that's why it's good to know them. But like I said, even if you don't, it's easy to derive them using your Pythagorean identities. And I've added them to my cosine double angle over here, so you guys can add those as well. So now let's go ahead and take a look at the power reducing identities. So for the power reducing identities, we use our cosine other forms. So we have the cosine of 2x is equal to 2 cosines 2 cosine squared x minus 1. So the power reducing identities, we want to solve for the cosine squared because that's going to be the power. So in order to do that, then I just have to divide by 2, oops, not divide by 2, sorry. Add the 1 first, the order of operations backwards. So cosine 2x plus 1 equals 2 cosine squared x. Then I can go ahead and divide by the 2. And now I have my power reducing identity, which is cosine squared x is equal to 1 plus cosine 2x divided by 2. And then for the next one, I can do the same thing with the cosine double angle other form with the sine. And so remember we said up here that the other form was 1 minus 2 sine squared of x. So then I do the same thing. I want to solve for the power. So I want to first take the 1 and subtract it to the other side. So when I do that, I have negative 1 plus the cosine of 2x is equal to negative 2 sine squared x. So to get the sine squared by itself, divide both sides by negative 2. And here, when we divide by the negative 2, I'm actually going to change the signs in my numerator so we don't have that negative in the denominator anymore. So this would be 1 minus cosine 2x over 2 is equal to sine squared x. So that gives us our other power reducing identity for sine. And of course, we know that tangent is going to be sine squared divided by cosine squared. So we could say that the tangent squared of x is equal to sine squared, which is 1 minus cosine 2x over 2, divided by cosine, so 1 plus cosine 2x divided by 2. And of course, if you have a fraction divided by a fraction, you multiply the reciprocal. So 1 minus cosine of 2x divided by 2 times 2 over 1 plus cosine 2x. And of course, these 2's cancel out. So that means that the tangent power reducing identity would be equal to 1 minus cosine of the double angle, or 2x, divided by 1 plus cosine of 2x. Now, we don't use the tangent power reducing identity as much, and it's easy to also find by as long as you know sine and cosine. So I don't make you memorize this one, but you definitely need to know how to get cosine squared and sine squared. But like I said, it's not hard to find the tangent power reducing identity. So now we use these identities in order to help us find the half angle identities. So let's go ahead and start off with the cosine squared x. So if I want the half angle identity, I'm going to use that identity that I have up there again. So we use our power reducing identity. So we have cosine squared of x is equal to this, which we just showed how to do that. So first we need to get rid of that power. So remember, when you get rid of the power, you take the square root and you need plus or minus. So that becomes the cosine of x equals plus or minus the square root of 1 plus cosine 2x over 2. But of course, we want the half of that angle. So right now we have just the full angle. So to get half the angle, we actually divide the angles by 2. So notice when you do that, you end up with the cosine of x over 2, which would be the half angle, is equal to plus or minus the square root of 1 plus cosine. Now 2 over 2 becomes 1, so the cosine of x over 2. And of course, we can do that for the sine power reducing identity as well. So in this case, we would get the same thing, take the square root. So this would be sine of x is equal to plus or minus the square root of 1 minus cosine x over 2. And then, of course, we want the half angle of that. So I divide the angles by 2. Oops, and I forgot my 2x there. So cosine 2x. And then the half angle. So divide that by 2. So we get the sine of x over 2 is equal to plus or minus the square root of 1 minus the cosine of x over 2. So now I have my cosine and my sine half angle identities. So just going to go ahead and move those over here. That's my cosine and my sine. And again, we just used the power reducing identity to help me find that, which comes again from your double angle formulas. So then the next part we want to do is find the tangent half angle identity. And again, you can find that by doing sine divided by cosine, or we can use the formula that we did up here. So if we did the same thing, you would end up with the tangent of the half angle. So x over 2 is going to be equal to plus or minus the square root of 1 minus cosine of x over 1 plus the cosine of x. And we showed how to get the 1 minus cosine x over 1 plus cosine x above. So then that would give me my tangent half angle identity. Now, for the tangent half angle identity, we do have other forms of that. So if we were to rationalize the denominator by multiplying by the conjugate of the denominator, so 1 plus, so root 1 minus cosine x over 1 minus cosine x, that would cancel out the denominator. So just to show you the other forms that we have, I'm going to just set them equal. So just to show you the other forms, if I multiply this by the conjugate of the denominator, 1 minus cosine x over 1 minus cosine x, and FOIL out the numerator and the denominator, so my numerator, notice that you would get 1 minus cosine x, so you're going to have um, 2 of those, so that would actually cancel out your radical. So that becomes 1 minus cosine x over, and in your denominator, you would have 1 minus cosine x times 1 plus cosine x. So if you FOIL that out, you get 1 minus cosine x plus cosine x minus cosine squared x. And of course, that cancels out your middle term. So you have the square root of 1 minus cosine squared x, which we know by the Pythagorean identity is equal to the square root of sine squared x, which we know is equal to sine x. So 1 minus cosine x over the sine of x. So this is an other form of the tangent half angle identity. And so these would be the other forms that we have for the tangent of x if we were to similarly multiply by the conjugate of the numerator. So you do want to know these other forms because usually it's nice to use these other forms since they do not have radicals in them, so you don't have to worry about the plus or minus. So the other thing we want to talk about is the plus or minus in front. Like, how do you know when to use the plus and how do you know when to use the minus? So the sign in front, of course, is going to depend on what quadrant your half angle lies in. So the sign in front, so of course that means the plus or minus, depends on what quadrant x over 2 lies in or is in. So let's go ahead and take a look at some examples because that will kind of help us. So we're going to find the exact value using the half angle identities of the sine of pi over 12. So I first would probably want to write down my half angle identity. So the sine of x over 2 is equal to plus or minus the square root of 1 minus cosine x over 2. So for the half angle identity, I know that I want to figure out what quadrant is pi over 12 in, so you could put that in degrees if you need to, or you can look at the decimal. So I actually know that this is in quadrant 1. So since this is in quadrant 1, I know I'm going to use the positive answer for my solution. So for this, now I need to figure out what x is equal to, because remember, we're doing half of the angle. So pi over 12 is the full angle, but we only want half of that. So you can set up a proportion to solve for x. So cross multiply, and you get 2 pi is equal to 12x. And again, we're solving for x, so 2 pi over 12 is equal to x, which of course reduces into pi over 6. So that's what we're using for x in my formula. So we're just going to go ahead and rewrite that out with our x. So we have the sine of, now our x is pi over 6. And 2 always stays in your formula because that's why it's called the half angle identity. So then we're using the plus because we're in quadrant 1, the square root of 1 minus the cosine, and we just said x was pi over 6. You don't want to use that pi over 12 because it's not in your unit circle, won't give you the exact value. So now I can go ahead and figure what this is out using my unit circle and just simplifying. So I have the positive root 1 minus, and we know that the cosine of pi over 6 is equal to root 3 over 2. And then we want to simplify this, so I need to change that 1, and we can multiply this by 2 over 2 to get a common denominator. So then that becomes the square root of 2 minus root 3 divided by 2 in my numerator. And all of that's being divided by this 2 here, so 2 over 1. And of course, that's all underneath the radical. So then if we keep going, we would have next, when you have a fraction divided by a fraction, you multiply by the reciprocal. So that's going to be equal to the square root of 2 minus root 3 over 2 times 1/2. And of course, when you multiply fractions, you multiply straight across. So we get root 2 minus root 3 over 4. And of course, we don't like to have fractions underneath of radicals, so we're going to separate that. So that becomes root 2 minus root 3 over the square root of 4. And we know the square root of 4 is equal to 2, so this is really equal to root 2 minus root 3 divided by 2. So this would be the exact value of the sine of pi over 12 using my half angle identity. And so of course I can do the same thing for the tangent of 7 pi over 8 using my half angle identity. So for this one, I don't like to use radicals, so I'm going to use my other form. So it's easier when you have one term in denominator, so I'm going to use this form right here. So that this is going to be equal to, or actually we'll just like write down the identity I'm using first. So the tangent of x over 2 is equal to 1 minus cosine x over the sine of x. So first of all, we need to figure out what quadrant 7 pi over 8 is in, and that tells me my sign, but well, actually we don't need to do this because we're not using the radical. So, but if I did need to do that, I could put it in terms of a decimal, or I could go ahead and look at the fraction or the degree form. And so this would actually be in quadrant 2, but again, we don't need that because we don't need the sign. But if we did, we know that the tangent, all students take calculus, so in quadrant 2, the tangent would be negative. So for this, I need to figure out what the half of my angle is. So we have 7 pi over 8 is equal to x over 2, so cross multiply to solve. So 7 pi times 2 gives me 14 pi is equal to 8 times x. And then of course we can divide by 8. So we get x is equal to, and this reduces into 7 pi over 4. And so that is what I'm going to use in for x in my formula here and both these x's. So we have the tangent of 7 pi over 4 is equal to 1 minus the cosine of, 7 pi over 4 divided by 2 is equal to 1 minus the cosine of 7 pi over 4 divided by the sine of 7 pi over 4. So then, of course, we are going to be using our unit circles. And if you recall, 7 pi over 4 is in the fourth quadrant on my unit circle. So we need to find the cosine and the sine of that. So we have 1 minus the cosine of 7 pi over 4 would be root 2 over 2 divided by the sine of 7 pi over 4. So since that's in the fourth quadrant, we know that's negative root 2 over 2. And then of course we're just simplifying. So in my numerator, I need to get a common denominator. So I'm going to multiply this by 2 over 2. So that becomes 2 minus root 2 divided by 2 all over negative root 2 over 2. So now that I have a fraction divided by a fraction, I can multiply by the reciprocal. So I would get 2 minus root 2 over 2 times 2 over negative root 2, or you can put the negative in the numerator, doesn't matter. So when we do that, these 2's cancel out. So I'm going to take this and put it back in the numerator just to make it easier. So when I do that, I get negative 2 plus root 2 over the square root of 2. And of course, we don't like to have radicals in our denominator, so we need to rationalize that by multiplying by the square root of 2 over the square root of 2. So when I do that, that's going to be equal to, I'm going to distribute to here and to here. So negative 2, the square root of 2, plus root 2 times root 2 would just be 2 over, and same thing in the denominator, so 2. And then we can see that that simplifies because we have 2's and everything, so that's really 2 root 2 over 2, so negative root 2 over 2, plus 2 over 2, which becomes negative root 2 plus 1. And now we found the exact value of the tangent of 7 pi over 8 using my formulas. So the next thing that we want to do is we're going to use those formulas to find the double angles for sine, cosine, and tangent. So we're going to keep going. So for the next part for this, if we want to find the double angle formulas, we need to remember that we have to use our formulas for this. So we have the sine double angle formula. So recall the sine double angle formula is 2 cosine x times the sine of x. So that means I need cosine and sine. So for this, it gave me that tangent of x is equal to 3 pi over 4, and it gave me that x is in between pi and 3 pi over 2. So pi and 3 pi over 2, of course, we know is in quadrant 3. So for this, that means I'm going to have to make a triangle in order to figure out my sine and cosine of x. So for my triangle, we know that we're in quadrant 3. So for this, if I draw my triangle in quadrant 3, we have x. Tangent is the opposite over adjacent, so 3 over 4. And we know that these both have to be negative because x and y are both negative here. And then we had to figure out the hypotenuse, so negative 4 squared plus negative 3 squared, which gives us 5 for the hypotenuse. So this is 3, 4, 5 triangle. So now we know that the cosine of the angle is equal to adjacent, which is negative 4 over hypotenuse, and the sine of the angle would be equal to the opposite over adjacent. And now I can substitute those values in for cosine x and sine x. So this would be equal to 2 times negative 4/5 times negative 3/5. And then I'm just going to multiply straight across and then simplify. So that gives me negative times a negative, which is positive. So positive, this is really 2 over 1. So that would be 24 over 25. Then I'm going to do the same thing for cosine. So cosine of double angle, I can use my other forms if I wanted to, or I can use my actual cosine double angle identity, which is cosine squared x minus sine squared x. So we'll go ahead and use that one. So in this case, when I substitute in cosine and sine, the cosine of x was negative 4/5, and we're squaring that, minus the sine, which is negative 3/5, and we're squaring that. So for this, when we square and simplify, so we have 16 over 25, and this becomes 9 over 25. So 16 over 25 minus 9 over 25 gives us 7 over 25. And then for tangent, we can do the sine double angle formula divided by the cosine double angle formula. Or because we were given tangent, we could actually use the tangent double angle formula, just whatever you prefer. So sine would be 24 over 25 divided by 7 over 25. So that's 24 over 25 times 25 over 7 because you're multiplying by the reciprocal. So notice we get 24 over 7. And of course, we can do the same thing for our half angle identities for sine, cosine, and tangent, given cosine of x is equal to 0.4 and x is in between 0 and pi over 2, so this would be quadrant 1. So let's go ahead and do that now for the half angle identities, just so that we can practice those. So for this, first thing I'd want to do is go ahead and set up a triangle in quadrant 1. So my triangle in quadrant 1 would go here. So this is x. Um, and we need to figure out, and actually, I don't even think we need to figure out what our other values are, but we can if we need to. So first of all, 0.4 as a fraction is 2/5. So we know the cosine, whoops, I wrote 2/3, 2/5. So we know the cosine would be the adjacent over hypotenuse. So then you could, of course, then solve to figure out what this other length is, but really we don't even need that because for sine half angle identity, recall that the sine half angle identity, and it's telling us that x is in quadrant 1, so that means x over 2 when we divide it out. So if I have 0 is less than x, which is less than pi over 2, if I divide each term by 2, because that would be the half angle, this still gives me 0 is less than pi over 2, which is less than pi over 4. So that means my angle is going to definitely be in quadrant 1. So the sine of x over 2, we're using the positive answer, so this would be plus the square root of 1 minus cosine x over 2. And so cosine x is actually equal to 0.4. So then we would get 1 minus 0.4 over 2. And so 1 minus 0.4 over 2, you can just plug into your calculator, hit the math fraction key, you get 3/10. And of course, we don't like to have fractions underneath radicals. So that becomes root 3 over the square root of 10. So then rationalize that by multiplying by roots 10 over roots 10. And you would get root 30 over 10. And so that's my answer for the sine half angle identity. Then, of course, I can do the same thing for the cosine. So the cosine x over 2 would be, again, the positive radical. So now for the cosine, instead of 1 minus cosine, it's 1 plus the cosine of x over 2. So that would be equal to the square root of 1 plus 0.4 over 2. And so if we put that in as a fraction, we get square root of 7 over 10, which of course we want to rationalize the denominator by multiplying by roots 10 over roots 10, which gives us root 70 over 10. And then of course then tangent is the last one. And the tangent is of x over 2 is going to be sine over cosine. So the sine x over 2 divided by the cosine of x over 2. So in this case, you would get root 30 over 10 divided by root 70 over 10. So root 30 over 10 times 10 over root 70. So those are going to cancel out to leave me with root 30 over root 70, which we can actually simplify because 30 over 70 is just 3/7, and then multiply by root 7 over the square root of 7. So when you do that, you get root 21 over 7. And the very last two problems that we're going to do are verifying the identities. So this is like what we did before. So we're going to use our knowledge of our identities to verify this side equals this side. So remember, you can only work with one side at a time. So usually you want to work with the side that looks more complicated, so the right side in this case. So I see secant and cosecant, and this is cosecant of 2 theta equals that. So the first thing I'm going to do is I'm going to change this into sine and cosine because I think that's going to help me. So this would be 1/2. Secant we know is 1 over the cosine, and cosecant's 1 over the sine. So when I do that, I get 1 over, because when you multiply fractions, you multiply straight across. So 2 cosine x, we forgot our x is there, times the sine of x. And we know 2 cosine x sine x is really the double angle formula for sine. So this is 1 over the sine of 2 times x. And I guess I should have used theta, but that's okay. So if this is, just pretend this is an x here instead. So then for this, 1 over the sine of 2x, we know then by our reciprocal identities, that would be equal to the cosecant of 2x. So now this side equals this side. So we can do the same thing for this identity over here. So if I want to solve this identity, I would probably work with the left side in this case. So if I see something squared and there's no parentheses over here, that means I'm going to multiply that out. So I have the sine of theta plus the cosine of theta times the sine of theta plus the cosine of theta minus 1. And then if I FOIL this out, I get sine squared theta plus sine theta cosine theta plus cosine theta sine theta plus cosine times cosine would be cosine squared theta. So notice you have these two terms are like terms. So we have sine squared theta here, and we have a cosine squared theta. So I'm going to put those together. Oops. And then we have plus 2 sine theta cosine theta minus 1. So remember that sine squared plus cosine squared is equal to 1 by the Pythagorean identity. So now we have 1 plus 2 sine theta cosine theta minus 1. So 1 and 1 are going to cancel out. So 2 sine theta cosine of theta is actually equal to the sine double angle. And therefore we are done. And that's all we're going to do. So again, it's really important that you know your identities. So that's why we went through how to derive all these. So even if you, forget your identities, as long as you know how to get the double angle identities using your addition subtraction identities, you could always derive how to get these other identities. And then of course we can use them to help us solve specific problems. So we'll go ahead and practice these in class.